G'day, I'm Jacob from Make Science Fun. Thanks for joining me today. So you've got a science fair project coming up and you want to do something with a fidget spinner. Is it possible? Of course it is. I'm a science teacher, 21 years I've been teaching. I've marked hundreds of science fair projects. What your teachers are looking for is something that answers a question and is slightly interesting. So with this fidget spinner, a good question that you could ask is, does the angle at which it spins affect how long it spins for? So that's a great question to have. A hypothesis might be, I think that the fidget spinner will spin best at 0 degrees. Or you might hypothesize that the fidget spinner might spin the longest at 90 degrees. Or you might even think that it's 45 degrees. Now, of course, you don't need a robot. You can just hold it in your hands like this at different angles, but you'll probably get tired. That's all right, you're young and strong. So what we need to do is we need a big protractor. Now I've got one here, and I'll set up the to exactly 90 degrees. That looks pretty good, 90 degrees there. And I'll get the smartphone with the stopwatch ready. That's ready to go. Now, you could spin it up. You could spin it up with your finger, that's fine. I'm going to use a high pressure hose. So now press start, and so it's off. Now let's record our results. I'll get the computer going. Now Excel spreadsheet. Excel's an excellent piece of software. I'm going to open up a blank workbook. I'll enlarge it a little bit, and in cell A1 I'm going to call it the angle. And our first angle was 0. The next angle we're going to do is 15, then 30. Now let me show you a little trick. If you highlight those three values, grab that little square down the bottom and drag down, it will actually recognize that there's like a trend there, and so you don't have to type in all the values. Okay, this is about to stop, and so we're at 53 seconds, 55. Maybe it will keep going for a bit longer than I thought. I want to have some times in there, and so I'm going to add another row. So I insert a row, and I'm going to go time in seconds, of course, and that will be the first one. And we're going to do a second and then an average. Stop. Okay, 2 minutes 35, that's 120 seconds plus 35, so that's 155 seconds. We put down 155 seconds, and really we want to repeat the experiment. We can do that after though. I'm going to go to 15 degrees now and do a tilt down. $15, reset that and get it going. Has to be started. That's it, full speed, press start. Now notice how important it is that it starts with the same speed each time. You have to control your variables. So the starting speed is a very important variable to control. The actual type of fidget spinner that you're using is also a very important variable to control. What we're changing is called the independent variable. Now the independent variable is actually the angle. The independent variable is the angle, and the time of spin is the dependent variable because it depends on the angle. Well now, oh, 15 degrees, it's about to stop, and it's 2 minutes 30, 2 minutes 31, 2 minutes 33, and stop, 2 minutes 37. Which is 158 seconds. So it actually went slightly longer. That's interesting. Oh, let's try 30 degrees, shall we? And start. Off it goes. And stop. 120 plus 37, 157. Oh, it's so close. At this stage, it doesn't appear to be making much of a difference, the angle. Oh, that's let's try 45 degrees. There we go. Stop. Probably an extra 3 seconds. So 2 minutes 30. It's 150 seconds. Ooh, that's our shortest time yet. So maybe the angle does affect the time of spin. Let's try 60 degrees, eh? 60 degrees. Sounds like a plane taking off. All right, 60 degrees, let's go. Slowly, 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 getting ready. Stop. 2 minutes 20, that's 140 seconds. That's definitely the shortest time yet. Let's go to 75 degrees. There we go, 75 degrees. Reset. Ready, set, stop. 2 minutes and 7, that's 127 seconds. Dramatically dropping. And so now for our final one, let's do 90 degrees. Stop. That's 111 seconds. That's the shortest time yet. Okay. Now let me show you how to graph this. So that last time was 111 seconds. Now really you want to repeat each of those angles, but for the sake of time I'll just make up the value. So I'll go 154, 157, I'll go 1 second under each one. Okay, 151, 139, 126 and 110. Now we want to find an average, and the average will go in that cell there. To find an average, we're going to tell Excel that we want to calculate something for that cell. So we go equals the average, type in the word average and start the bracket, and we can drag the two values that we want averaged, enter brackets and press enter, and it gives us the average. Next, we can drag the bottom right hand corner and it gives us the averages like that. It drags the formula down. The next thing we want to do is graph this. So we want to use what's called a scattergram. So I'm going to go insert, and I don't want a line graph, I want a scattergram. That's a scattergram there, an XY scattergram. I need to select that set of values, and then I press Command and I can grab that set of values too. The angle will be my horizontal axis. That's what we change. That's the independent variable, the angle. And the time in this case will be the vertical axis, or the dependent variable. Let's go Excel, scatter. Let's see what we've got. This is looking great. I love it. I'm going to add a chart element. I want a primary horizontal. I want a primary vertical. And so I can go, type down here, the angle in degrees, and I can do the average time, label on this axis in seconds, put the units, the chart title, it's the fidget spinner experiment, so fidget spinner. And I'm going to highlight those points by just pressing on one of them. It doesn't matter which one I press on. And if I right click and add a trend line, it comes up with a linear trend line. I think it's clearly going to be a curve. So let's try, it doesn't like logarithmic. And so I'm going to try again, add a trend line. Let's try polynomial. Oh, that graph looks pretty good. I need to I want it to be a solid line. And so I select solid, it's not going to be dashed, and there it is there. And so that graph clearly shows that as the fidget spinner is held more and more vertical, it slows down more quickly. So what this experiment shows is that if you want to win a fidget spinner contest, for the one that spins the longest, you want to hold it horizontally. Now, if this was a science fair project that I was doing, I wouldn't just do one variable. I'd also test, how does like jiggling the fidget spinner affect how long it spins? I'd also probably try doing things like adding different lubricants. So I'd pop the plastic off and I'd put a drop of vegetable oil and I'd find out how long it spins for. And then I'd put a drop of detergent and seeing how long it spins for. Some soap, some water. Do it dry as well, because doing it dry would be your control. Anyway, I hope you found this video helpful. I've got other science fair project ideas on my YouTube channel, Make Science Fun. You should do a search and that might trigger some ideas that you want to do and help you along. All the best. I hope you do well. Okay, bye for now.